Welcome. This presentation stems, the subtitle is Syntax and Structure of Transformed Ruby, and stems from lessons we learned in the BPF VO case about our transformed Ruby code and improvements there. Mostly we will look at code, Ruby code and NapaBasic, and compare them, but this should be, let's say, management friendly presentation in the sense that the code is very simple and it should be clear, to everybody when we are looking at some comparison what improvements have been done. And in the end, we will have some suggestions and, let's say, political topics about what should we do. Very quick overview. This has been presented often before, but the idea of the GUI transform is to take our widget definitions and most of our macros, which are expressed in NapaBasic and widget NDS files. These are relying on set of GUI-C framework made by Ilkka Priha, and being one of the worst black boxes of unknown or ununderstood functionality in Napa. And in the transform, we have these red arrows which represent the transformation rules, which produce from these blue input files the light blue output files, which are XAML files for the widget layouts, and then Ruby files for the NapaBasic callbacks or the NapaBasic macros. And these are then working on the yellow boxes, Ruby and C# GUI framework, and just like the old gray C framework, both frameworks then are connected to the Napa Fortran core and can use services there. There's many other older presentations about this, the general idea of GUI transform, so I link here one particular presentation file in the project's technology renewal directory. So we are not talking here today. We are talking only about specific aspect of the GUI transform, mainly the syntax produced for the Ruby files. So why do all of this? We have a great legacy burden of Motif and NapaBasic, and Juha Heikinheimo was putting this in a colorful way a few years ago. Even blind granny can see that we must get rid of NapaBasic. And he added later, we must even get rid of Fortran, and then we said, okay, just cool down, let's take the NapaBasic first and go stepwise. And the irony of this Dilbert here is that in the original strip it says step away from Windows XP, and still Windows XP is much more modern technology than NapaBasic. In 2009, when we started working on the main part of the GUI transform, we had some assumptions how the end result would be. One particular assumption was that this garbage in, garbage out, meaning that we know and we realized on the way of going that we have lots of bad NapaBasic in many different ways, either using weird syntaxes in order to do weird things because of the low expressive power of NapaBasic, or having lots of duplication or other special aspects needing refactoring. And we were assuming that naturally we cannot fix these things in the transformation. If we have bad code in the input, we will have bad Ruby in the output, and we will need anyway to do some refactoring to the results if we want to get good quality Ruby code. Our aim first priority aim was to get working code, Ruby code that when executed performs exactly the same things as the corresponding NapaBasic, so the end result would work as the original products. And we were, willing to sacrifice aspects of the syntax and readability of the output in order to obtain this goal. Also, we were assuming at that time that we will run the transformation for all of our products, for everything we have in NapaBasic, and we will release all the products in VPF version at the same time. Now all these assumptions have been, challenged. We know we have been releasing products and making a more stepwise approach here. And now this presentation is about this assumption about having necessarily complex Ruby syntax. And much of this stems from the VPF VO case starting in 2013. Of course, it started much earlier. It's impossible to say when did we start work on the VPF VO, because all the transformation rule development starting from 2009 has been, developing towards all products being transformed. This represents about 100,000 lines of code base, which is in Ruby and XAML now, and we have quite well working product here as a case. And one reason for significant work that we did after stopping the transformation was that we were improving the quality of the code after the transformation with the platform team. Partly this was because we assumed we as a team would give this maintenance development of this product afterwards to completely different people who are not participating in transform. So we wanted the code base to look as good as possible, but it was having still significant impact for the duration of the project. And during this refactoring after the transformation, we noticed many kind of patterns. We were finding several kind of bad syntax or duplicate syntax in different parts of the code, and we were sort of hand refactoring many similar cases, and that brought the idea that perhaps we could implement these improvements in the syntax of the output already in the transformation machinery, which would eliminate in the next subsequent transform products, would eliminate much of the need of after transform refactoring, and also eliminate the errors that always when we do refactoring there will be errors, and there will be this cycle of improvements. Of course, what we also did during this VPF VO case, we were developing much more unit tests and code coverage tools and tracing tools and other tools that were aiming to ease the debugging and keep verify the quality of the product, and all this work is also benefiting the transformation of the future other products. So now we will go through top 10 improvements that we have been doing in the past 2 months for the syntax of the transformed Ruby codes. And in each case, I will compare some examples of NapaBasic in the original sources, and then the existing Ruby transformed code, and in some cases also the Ruby transformed code as they were, before the recent improvements. So from 10 to 1. 10 is remove redundant parentheses. So here's example of a calculation formula from macro allb vap dense, which is included in the transformation. And in the old transformed Ruby, there were several extra parentheses coming to this formula, unnecessary parentheses that were put there for safety in order to ensure that we don't lack parentheses. In some critical case, we were generating many unnecessary parentheses. Whereas now, the number of parentheses that are present is optimal. It is only those that are really needed for the syntax. Number 9, string operations. People who have been working with strings in NapaBasic know that sometimes string manipulation is not very convenient. Here's an example of C and C where we are combining a parentheses, one variable, a comma, another variable, another parentheses. And now we are using in the new transformed Ruby very convenient Ruby string interpolation syntax where we can combine string literals and then insert values of variables there in between. Then if you want to check in NapaBasic whether a string includes a substring, you must use this rather awkward len function. And you must check whether the length of the string and the substring is greater than 0. It's not very apparent to new programmer of NapaBasic that this means checking a substring. Whereas now we are using the powerful Ruby regular expressions and transform this into test of a regular expression with the substring. Also, when we check in NapaBasic whether a string is beginning with another substring, we must take the substring of rule beginning with 1, starting from positive 1 and length of 2, and check whether that is st. Now, on a higher level, this expression means, does this string rule start with the string st? And this higher level rule we can express now very nicely with regular expression. This means starts with st. Yes, question here?
Do we still have the possibility for checking is string character number 4 and 5 that one? So if this st would now not be
yeah, we don't have the monitor on here, so you
just assuming that it already works. I'm now speaking into the microphone. I was asking a question that the 1, 2 st is asking for, does the string start with s and t, but would there still be the possibility, let's say we would in the old way write SBS rule 3, 4 st, that we could check is character 3 and 4 still s and t?
Yeah, of course, everything before this simplification applies only for the special case where the SBS is referring to the beginning of string. Now SBS, the substring, normally is transformed in Ruby to indexing operation. And before this improvement, all the SBS statements were transformed to this indexing operation. And now this special case is transformed to the regular expression match, and all the remaining cases are still transformed to the indexing operation. Actually, either the indexing operation, looks slightly similar. In this slide, I don't have the NapaBasic before this, but all the other cases remain as they are. Everything is supported. These improvements do not reduce, everything that has been working before works also with these improvements. Also checking for the ending of the string, we can, there's very many cases where we are checking the ending of the string with SBS, and now they transform also to regular expression check with the dollar signifying the end of the string. Now in the blue parentheses here, I have been just writing how many cases have been improved in our transformed code base based on these. So we can think of the hand refactoring we were doing in the VPF-VO code base, and you can think, for example, every case like this here, the string interpolation, it takes at least a few seconds, perhaps a few minutes, a programmer to fix individual case like this, and there's also the possibility of making some error there and then having to fix the bugs of this error. But now with this one rule change, we got like 29,000 cases fixed with one rule change, so it's much more efficient. Then also very common, less common, but still few hundred cases is a more complex substring expression where we are in fact checking whether a string, where we are extracting a substring from a string before some other. And again, it looks quite ugly if we look at the original substring expression, but we can deduce with some specific parameters this translate to substring before or substring after. Then for if statements, we have in NapaBasic very many one-line if statements where we have if something and then just one statement without then and without end if. In our previous transformed Ruby, we didn't support this single line if. Of course, we supported this NapaBasic, but we were always generating multi-line if statements in the Ruby. So we were getting these 3 lines, for example, here. But now, for simple if statements, we are generating 1-line Ruby if statement. Now you can note here that 1-line Ruby if statements actually have the if in the end of the line. This is Ruby specific syntax, but nevertheless it's 1-line if statement. Here you can also see how this UI set statement of the setting of the background color maps to the setting of the background color in a more simple attribute setter in Ruby. But this is not a recent improvement. This has been there already a long time. So I will not talk more about those kind of things. Number 7. If and assign. This is again, we have had about 1,000, more than 1,000 cases where in the original code, NapaBasic, we are setting one value for a variable and then we are conditionally setting another value. Now, again, the old transformed Ruby was just transforming exactly that, setting one value and then conditionally setting another value. But now we are converting that automatically to this kind of ternary expression where we are setting the value directly based on the value of the expression. So simplification. A similar case is when we have this is a more complex case of this same rule. Now here in this original NapaBasic, we don't have assignment at all. We have just MTF text enable undo. But if we look at the old transformed Ruby, we see it the MTF text enable undo has been transformed to setting of the undo limit property, the undo limit VPF property. So we have in fact been having in the old transform similar pattern, and that enables also this optimization rule to produce a ternary expression here, which looks very nice. And you can see the elimination of duplication here is even more because we have more complex expression here in the original and much more duplication in the original. A third case of eliminating and even more common here, we have over 3,000 cases that were simplified, where we have if, else, and if, and in the both branches of this if statement, we are assigning the same variable but to different values. Again, the old transformed Ruby was very similar to this in structure, but now we generate very efficient ternary expression and simplify huge number of code. More complex if-else expressions when we are comparing when we are in the all branches of the if expression, comparing value to some constants. This actually maps very nicely to Ruby case statement. NapaBasic doesn't have case statement, but as we had over 2,000 expressions like this, where we have long if-else, if-else-if statement, and then we are just comparing different values for same variable. And now we are generating case statements for them, eliminating the duplicate comparisons. And this can be even more efficient when the comparison is not for single variable, but for more complex expression. So for example, in AD, VESH, quant, we had if and then a complex formatting statement comparing to char, else if the same complex formatting statement compared to if. Now when this is converted to case statement, automatically we get this formatting statement only once and then the different results here. Then if else, we can also apply to regular expressions, because the Ruby case statement is wonderfully powerful. It can compare not only equality but also matching of regular expression. So for example, in AD-MGR browser, which is in the code base we are focusing at the moment, there was a very complex long case if statement where we are checking whether the type begins with loop, whether the type begins with cat, whether the type begins with MGR, and so on. And with the rule I was talking about earlier, these comparison statements were already converted to regular expression matching. And now when we kick in this case conversion, then they automatically simplify using the case statement. So these kind of different simplifications rules can automatically combine in powerful ways. So we get, two rules or more rules combining, producing very neat result here. And even for this thing, although you might think this looks like a really special case, over 700 different instances in the code base simplified. Now, these instances do not unfortunately count the VPF-VO, because the VPF-VO was already dropped from the transformation. So I'm a bit sorry, for the VO team that all these simplifications, they are not anymore benefiting them. You must continue doing those by hand as much as you want. If assignment extraction. Another very common pattern, 3,000 cases we found, where we had been in each part of if else statement, in each part, only thing that is done is assigning a single variable, the same variable. Now there's clear duplication here, and in the new transformed Ruby, we can extract this assignment out from the if statement. This is because Ruby has this powerful feature that every expression, every statement is returning a value. And for an if statement or case statement, the value of that statement is the expression that is executed in the selected branch. So with this extracted. And this can even combine to produce a ternary expression. So for example, in ADVE unit spin box, we had this comparison with the if, else, end if, where we had only assignment, and this now simplifies directly to single line ternary expression, and also the string expressions here look nice. Now, ironically, we do have in NapaBasic a calculator expression called IIF, which is like the ternary expression, but for some reason it's not very commonly used. It's much more common to have these kind of expressions, but now we get this for free joining the crowd. Quite late. Okay, it's a quite late addition. Yeah. So and there has been not much effort into simplifying these. Perhaps when I was implementing these different improvements, of course I was also thinking, well, could we also do this automatically for the NapaBasic code? So could we, now this is benefiting the transformed Ruby. It's not benefiting the original NapaBasic, and this is based on the assumption that this original NapaBasic will be replaced by the Ruby. But of course, if we see that for some parts, this NapaBasic will live for a very long time, we could conceivably do similar automatic improvements, automatic refactorings for the original code. Of course, in many cases, they couldn't be done because NapaBasic doesn't have the features of Ruby, but in some cases, like here, we could conceivably use IIF. This is an example of combining two rules. So in ADVE HA quant, I showed this example already earlier, but not in the most powerful form. Here we had the complex expressions that were mapped to case statement, but at the same time in this each branch we are only assigning variable. So here it combines to have a case statement and extraction of the variable outside. So we are eliminating two different categories of duplication here in one go. Yeah, Will has a question.
Yeah, assuming the microphone is on. These are very impressive changes. One thing in this case and case 6 is that this AD format, I wonder, does that have side effects? In the old code it's run once or twice, but in the new code it's run only once.
Yes, that's a good question. We will talk about that a bit later with with another. So Will was asking whether some of these have side effects. Now, in this case, I can say it doesn't have side effects, but there could be conceivably another case where they would have side effects. So that has to be taken care of by the rules. And some of these rules, you know, although the change might look simple, some of the rules are quite complex because there are special cases exactly like this where the rule has to be more complex in order to apply the simplifications only to that subset of cases where the simplified version will be doing exactly the same. And actually this case comes exactly now. So elimination of unused variables, very, very neat thing. We don't have that in Ruby, but I can guarantee we have had 18,000 or more cases of assigning variables that are never used in NapaBasic. Now, the most common thing here is this dummy stupid @n, you know, that you can see everywhere where we have macros, because there are many functions, service functions like AD alternatives that are really getting, you know, all the parameters they really need as parameters, but they are in addition, instead of returning empty string, they return the number of items processed or something like that. And in 99% of cases, that value is never used, but we need this to fool the Napa command interpreter, you know, into not thinking that this result value is a command that needs to be interpreted. So it's a very annoying habit, and in the old transformed Ruby, these assignments and the unused variables were coming as well. But now, if this n is not used anymore in the subsequent code, it will be eliminated. And if we have several statements like this in a row, then recursively they will all be eliminated, because the last one will be first eliminated and then progressively all others. And even more, if this elimination results in a statement that is side effects free statement that doesn't modify any state, then the whole statement is eliminated. And again, huge number of dead code was found by this rule. In order to be on the safe side, for this rule, we of course have to define which statements have side effects and which do not have side effects. And in order to be on the safe side, I did it in a way of incrementally adding kind of statements that I know do not have side effects, and everything else is assumed to have side effects. But for example, TPV area does not have side effects, it just gets working area. So if this old VA is not used, then this assignment is eliminated and the whole expression is eliminated. And this can also lead into recursive elimination of blocks of code that are just dead code. Nothing like this we have in NapaBasic. User data to attributes. Everybody who's been working with widgets knows, because user data is the only way, it's the golden hammer to store state, store some kind of data in our present widget framework. It's used for everything. It's very, very commonly used. And so here are some expressions of user data getting and setting. And the old transformed Ruby is already a bit simpler than the original ones, but it uses this kind of user data. So each widget has a user data map, hash map, and then this hash map is indexed with the parameter and so on. But what we really want, we want just attributes, just other attributes. I mean, here we want really the widget to have work area attribute or line attribute, and now we have that. So now this setting user data is edit mode is converted just to setting is edit mode attribute to true. Now, in some cases, we still keep this kind of UD extension here in order to not have name conflict with some other attributes. But in some other cases, we can even eliminate that, and this complex thing of getting the number, getting the line, is just the attribute line. And then number 1, the loops. NapaBasic has lots of loops, and the loops are very old kind of for loops where we are using indexing variables. And these were converted originally to while loops. And the reason why they were converted to while loops is that NapaBasic unfortunately allows very dirty tricks to be done inside these loops. For example, this index variable can be inside the loop assigned randomly to some other value. And also the index variable can be after the loop be used in different ways. And Ruby up to loop or the Ruby for loop does not have these properties. So originally we had to transform the for loops to Ruby while loops, which is more complex, which is more primitive syntax. But now we have been improving the rules of the transformation so that in those 99% of the cases where the up to loop is sufficient and works for this case, then we are using the up to loop, which is much more efficient. So here this loop is transformed to this up to loop, 0 up to the end, do the loop variable and then the content. In this particular example, you can see that the content has been also simplified by the other rules. And number 0.
Wait.
Yeah, okay.
How do you, in this case, know to decrement the loop start and end period by 1? From 0 to length -1.
Yes. So this is another improvement. We have this discrepancy that in NapaBasic indexes of arrays go from 1 to the size, and in Ruby and C# and all most modern programming languages from 0 to size -1. And originally, and this is one improvement also that have been done now recently, but it didn't make the top 10. And this improvement in the original transformation, we had to have +1, -1, +1, -1 in very many generated Ruby code in order to convert between the Ruby index and the NapaBasic index and the Ruby index and NapaBasic index. Now 90% of those +1, -1 have been also eliminated because the transformation can intelligently recognize that a particular variable is used as an index variable, and then it will generate first to these statements -1. So to these statements, these indexings, it generated originally -1. As you can see here in the old transformed Ruby, we have steps I -1. But then together with this improvement, because this allows us to recognize I as an index variable, we shift this range, and then inside the loop we convert I to +1. And this leads to the -1 and the +1 to kill each other, simplify, and we just get 1. Very nice. But even better is coming. In most cases of the loops are actually loops over arrays. We are looping over array, and in NapaBasic we always must use an index variable from I is 1 to r size of quants, blah blah blah. And now most of these cases we have been able to eliminate completely the index variable and use the each loop of Ruby. Many modern languages have each loop, which means we just have so in the old Ruby we were doing the up to thing, but now we have the variable.each and then a variable for the item, but we don't have any index variable at all. We don't have to care of +1, -1, any kind of indexing. Of course, this only works for the subset of loops where this index variable is not used in any other way than indexing this particular array. But for those cases, and there's over 3,000 of those cases, it works very well. We have a question here.
Yeah, so two very small questions. Of course, you were saying that the first index of 0 is used in most modern program languages. That is why here it starts from 0 to use the up to. In some, yeah, exactly in that case, for instance, is it still a valid syntax to write 1 dot up to, or would this be wrong?
Yes, it is valid to use 1 dot up to, and I think one intermediate step here was such. You can even write 10 up to 100. It is just range expression. Yes.
Okay, and the second question to all of this great stuff that we have now seen, using this, well, .each is Ruby general, I would assume.
Yes, it's the property of Ruby, any kind of Ruby arrays. Yes.
But then there is additional stuff that we have specifically for Napa. Do we have, like we had explanation texts for the for loops or for whatever we do in NapaBasic? Do we also have some kind of documentation for these things which are now handled in Ruby, which were replacing the old things, in order to know how to use them now?
Well, the nice thing about Ruby, of course, is that Ruby documentation you can find anywhere. It's not confined to our company. So we have all the documentation about what a particular Ruby expression means. If we are talking of Ruby framework and Ruby syntax, we have worlds of documentation in books, books and internet. But if you were meaning whether did that answer your question?
It might have answered the question if we are not using anything in Ruby now that is not the common Ruby itself. If we did not write any Napa own Ruby functionality, which is not documented in the World Wide Web.
Yeah, we have our own Ruby GUI framework and C# GUI framework, and there is quite much code there also, and there is, I would say, not adequate documentation for that yet. So that will need to be improved through training or whatever. But indeed, that's a good point. We need some Napa-specific Ruby extensions and Ruby framework in order to bridge the gap between, you know, our Ruby code and the VPF framework, and the differences between the VPF framework and the Motif framework. There's quite many subtle differences, and we squeeze, you know, or we build a gap between those differences partly in our Ruby framework. Yeah, we have been trying to keep that in minimal so that the Ruby code you would see would be as clear and straightforward, and there would be no hidden weird things happening underneath. We have been aiming for that. But there is some framework involved, yes. Okay, this was the top 10 improvements, and now I invite everybody to go and look themselves. All our transformed Ruby codes are in work napa.ruby transform folder that has been there for years, and we are committing and checking in new improvements when they happen. One thing to note here, which we didn't now discuss, but this is already old thing. Already from the very beginning of the transformation, we have been including the original NapaBasic statements on the right-hand side as a comment in these transformed Ruby codes. So with this also, we try to ease our programmers' transition from using NapaBasic to Ruby, because if they see some Ruby and they don't really know what is this, they can look at the corresponding NapaBasic and see the correspondence, and then perhaps also understand better what is going on there. Okay, now to the political part. Why should you switch to use Ruby now? And these really we cannot say, anything in vacuum, why should you do something? We must always compare. And here the comparison is to NapaBasic. Why should you switch to Ruby from NapaBasic now? Ruby is well-designed, modern, widely used full language, unlike NapaBasic. Possibility for object-oriented and functional code, unlike NapaBasic. Good data structures, good library functions. If you go and look at our NapaBasic, both widgets and macros, just the lack of good data structures leads to horrendous code, where people are dealing with individual items because this string, double, integer array, this is all thing you have, and that is not good for everything. Well documented in books and in the internet, instead of this guesswork that we are involved by sending questions to each other, like, I found this weird NapaBasic, does somebody know what this means? And then we are talking to each other. Very good tools. We have IDE, like for example, I have here RubyMine IDE that I'm using every day. IDE with refactoring tools, IDE with syntax highlighting, modern IDE with searching tools. We have a unit test framework that covers not only the Ruby code itself, but we are able to unit test all the widgets and all the transform things. During this VPFVO project, we were investing significant work to extend our unit test framework so that we can test every single aspect of the GUI just like we would be using it manually, without any limitations. Code coverage, we were investing in making tools for code coverage and tracing, which, again, made the VPFVO project bit longer, but these tools are now all available, done, and benefiting any consequent projects. Much better performance than NapaBasic. Although Ruby is known as a slow language, NapaBasic is even much slower, despite the recent attempts to improve it. Good integration to C# and Fortran core. Now, of course, C# is the obvious alternative for using we didn't in the end use C# for the transformation because it is much more difficult to produce workable C# from our NapaBasic than workable Ruby. But compared to C# with Ruby, we have even better integration. We can use all the service functions and execute commands in a very natural and simple syntax. And finally, with this VPFVO case, we have sort of demonstrated the productivity and correctness of the resulting Ruby. And now, as you have seen now, as a bonus, we have much simpler and clearer transformed syntax as in the past, as an additional reason for switching to Ruby. So by using Ruby, you will get more value to Napa, and you will get more value to our customers. And as a developer, you should think of your career also and your skill set. If you are learning NapaBasic, your career is dead end. But if you are learning Ruby, you are valuable. And this is a win-win situation in job market. If we are doing things, if more and more of our developers are using good, modern, well-known languages, it's good for them and it's good for the company. It's not away from anybody. How to switch to Ruby? Now, the easiest case is to start using some transformed macro. So at the moment, we have over 4,000 macros that every time we are running the transformation, they are transformed to Ruby. We can look at some example here. We have here in the transform directory, we have subdirectory called macros. And this contains only over 4,000 Ruby files that are transformed from 4,000 macros. And here is one example, criteria description. This is a very simple, short example, but instead of running the criteria description with AI run as a NapaBasic macro, it can be run with the statement ruby.macro with the name and parameters. Very simple switch. And when this has been, well, I mean, we could, in principle, we could do this automatically. We could mass transform to use this. But of course, we would think that would be risky. So what I recommend now to all groups, whatever macros you have, when you know your macros and you know where they are used, try this. Start using the Ruby version of the macro. If it seems to work okay, then you can change all the calls to use this transformed version, and then you can delete the original one. When you do this, if you are unsure, we will help, platform team will help anybody to do this. And this is a very nice way, you know, we have been talking during this whole project, how can we ease the transition, you know, of our developers learning new technologies, you know, instead of slapping, you know, million lines of Ruby at them in one go. And this is a very nice way, because this all works with the Motif GUI. You can use these Ruby macros with the Motif GUI. You can stepwise start to use this, learn Ruby, do some refactoring, get the performance benefits, make some new features, whatever. Question here.
I have one question, because you said we're now in the political discussion, so this is only
No,
a political question.
I am advocating one way of doing things, yes.
Yes. I think this is really good if we replaced the existing macro NapaBasic code by Ruby code. I just would like to know, then of course, like it disappears from DB7 as a macro. Is it so that it is visible to any of our customers still as a Ruby file, or is this non-visible like the code that we write in other languages, like for instance our Fortran core? And if so, I would say it would even be good if it disappeared, because well, I don't think there are many companies like our company which is distributing the code freely with the product. But at least our customers seem to expect that they get the macros stored in DB7 and they can open them and modify them according to their needs and store it again in DB1 or 2 or wherever. Is this still possible with Ruby code, or is it just hidden, and do our customers accept it?
Yes, it is still possible. It is still possible, and they have been already for a long time, for 2 years or something like that, going to the installer. So if we open here, see Napa.
Hur då ska vi installa Napa?
I think it was.
Den program files.
X Napa Ruby, Napa Ruby. Transformed macros. So you see in the installed version of current Napa, already for the past 2 years, we have all these transformed macros. Now, we don't have, of course, we do not transform the encrypted macros. So those macros, we have been especially flagging that they shouldn't be seen. They are not part of the transformation anyway. But those macro and some macros are not part of the transform because of other reasons. We have at the moment about 4,000 macros part of the transform, and we have about 8,000 macros in total. That's another horrible problem why we have so many macros, but that's a different thing. Now these are in the transform directory. If you want to experiment and if you change to call some Ruby version of the macro, and if it works, and then you want to commit that, then what you should do also, you should move that macro file away from the transform directory, because that Ruby file is not part of the transformation anymore. And the transformed Ruby directory is occasionally cleared and replaced with the new transform stuff. So in addition of switching your calls to use Ruby macro, you need to move then the file away. But that's a separate topic. I can give another training about that, and you can come ask about that. But it's basically 2 small steps to do it for 1 macro.
This can be done also automatically.
And then I would recommend using Ruby for development of new features. When we are developing new features, I think we have perhaps too much the idea here that, okay, we need to do this feature. Who will do the Fortran? Who will do the NapaBasic? That's the implicit assumption. There is not even discussion what tools we might need to use. Now, recently, C# has been getting a bit more prominence, like, oh, should we perhaps use C# here as well? But in some cases, C# might not be the best thing. But for many cases where we have been doing new features as a combination of Fortran changes and then some macros, this could be ideal step forward. And we have so much examples, in our transformed codes how to do this. But indeed, remember also C#, and we just wish in the platform team that in every new development there would be one part where the developers would think, okay, which languages and which technologies I will use, instead of just doing it as always. And as the third thing, as the bigger thing, I recommend contribute to the VPF GUI transformation of the further Napa products. We have the VPF VO case now in the maintenance already, and now platform team is working together with some developers in India about the VPF manager framework and minimal set of some design Napa features. We are quite far in that, and then together with the Safety India team, we will look at the custom widgets and special requirements of the class NK manager, which will be our gold standard to see when we have the manager framework in VPF working. Then we have been seeing many questions about the loading computer recently. It's been sort of on-off story because at some point it was decided, the safety team will come to help us here, but then at some point we were switching more in the platform team for this VPF manager framework, but there's nothing technically stopping of doing this in parallel, stepwise, and looking how we are doing there. Every day we are transforming 500,000 lines of these codes. Then I was even having the guts to add steel here, although some time ago I heard it was decided that steel is not transformed. Now that statement in itself is, I would say contradictory statement, because the steel is every day transformed to VPF Ruby version of the steel. So only thing that can be decided is that nobody will, take a look, and nobody will debug, and nobody will try to make it work. But I assure you, every day it's transformed, and now it's transformed even more clean Ruby code than ever, without any extra effort. Okay, so the horse is at the well, and I would say regarding GUI transformation, platform team is done. We have been taking the transformation rules as far as we can, with our own expertise. Now when we work, with other products, like we did with the VPF VO case, we needed the help of the VO experts to help us in finalizing the final bug fixes. But even though we had quite many months, after the stopping of the transform, one very interesting outcome was that we didn't afterwards, many of the bugs we fixed, only 3 bugs we were able to trace to the transformation rules. So the transformation rules for the point of completeness of producing working code are in quite good shape, and we have very extensive test cases, so they should keep in shape also with any of these changes. So we need the involvement of the teams, and whatever commitment there was in the company 5 years ago for doing this, now when we have almost complete rules and good syntax, it would be, in my opinion, terrible ways to just throw away this thing, even when there's no realistic other alternative that is presented. So push it to the front. Again, in this company, we have seen so many half-hearted efforts of starting to do something, grinding, going to halt, then deciding with big effort to do something else. Let's this time try to push it to the end, and then we have better code base, and we get rid of the exceed, and we get rid of the motif, and we get rid of those technologies. As long as we have single line of NapaBasic widget code, we are stuck with those technologies. Okay, Still 5 minutes for questions.
I have one question.
This strip represents my feeling that sometimes there has been opposition to the idea of GUI transformation that might not be always based on full understanding what it is, what is meant to be, and so on. Meanwhile, I will try to, if some online people have questions, I will try to see the link.
Robert, can you hear
discussion
me?
here.
You're not checking your chat window.
I'm really interested in this discussion that could and I think should spring forth from this presentation. When I think of my daily work, I don't deal with NapaBasic, and I don't remember, in my nearby environment, people who do this NapaBasic development. But I'm quite sure there's lots of those people. I'd just like to know what is currently going on in NapaBasic, in Napa company in general. I'd like to know what could we move to Ruby now. Maybe you know, Robert, maybe somebody else knows more, but I'm interested.
Yeah, it's a good question. I don't have best understanding of that. Of course, when we look at different teams' roadmaps and different higher level planning, we usually see only boxes related to some product. Usually it doesn't specify the technologies there. So my assumption has been that the activity involved in developing things in NapaBasic is significant. We can of course approach this question from two directions. We can go through the top level projects and look at the technologies there, or we can also do so that we look at our commits, in our source code repository in Git, and we look how much commits are coming that are editing NapaBasic, how much commits editing Fortran, how much commits editing other languages like C#. But yeah, I don't have statistics on that. Then do we have some? Yeah, we have online question. How easy would it be to debug transformed code? I would say mostly easier than NapaBasic. There are different advantages, and we can, again, depends what we compare it to. We have different kind of tools for debugging. There are some advantages and some disadvantages compared to other cases. For example, the stepwise execution of Ruby and putting breakpoints is not on as good level as, for example, in debugging C#. Whereas things like stopping somewhere and evaluating variables and performing manual, like interactive statements is on a quite good level. Then one very good thing is the exception support. So because Ruby has good exception support, usually when something bad happens in the low level, we get very good error report with very good stack trace showing exactly what happened, where, and why. So the seeing already from the error message what went wrong can be much easier than in NapaBasic. Other debugging tools.
Maybe you could just comment on what, for instance, Julian answers a bit more in particular. That it works if the debugger is attached. Which kind of debugger?
Yeah, Julian is talking about. We can use Visual Studio as a debugger, but the .NET Ruby integration to the Visual Studio is not on a very good level, and Ruby never will be. So we have been. Some people use it and say it's okay, but for example, I myself I use other methods that perhaps are more similar to the step mode of NapaBasic in their working. One great advantage that we have with our Ruby code base that is better than, for example, debugging C# or Fortran is that we have made framework again during the VPF-VO project where we can make any change to the Ruby code while we are running the full product. We are running VPF-VO or we are running the VPF manager. We make any change in the Ruby we save the file, and automatically it's loaded and working. It is changing the definition. We can change the content and definition of any method without recompiling anything, without restarting anything. Even easier than in the Napa widget editor, we can change NapaBasic. So that is one advantage of making debugging more efficient.
Robert, I have one question. Can you hear me?
Question you were mentioning beforehand, but then I think, well, the question is already asked.
What happens to thousands of NapaBasic macros in a customer SysDB when we are switching to Ruby? Again, what I said about macros, we don't have plans of switching to macros in macros to Ruby in one swell sweep. Only those macros that are directly connected to the GUI, that are integral part of some widget operation, they will be converted in mass conversion to Ruby. But macros, NapaBasic will be there, will be executed. The Fortran core is not touched by this, and the Fortran core is the one that executes NapaBasic macros. So nothing will happen. Anything I have said here, anything in GUI removal is not affecting customers being able to run their macros. Except if those macros are trying to do some GUI manipulation, then of course that GUI manipulation, if it's motif specific, that will not work in VPF Napa. Okay.
They ask you for putting the speakers on, maybe they have longer questions.
Okay, I will try to do that. Where should be? Yeah, we have very bad problem with the audio here, so I cannot connect people from online to be heard here, or I cannot hear. So let's use online people. Let's use the text chat here. Where should the Ruby macros be stored? So at the moment, the transformed Ruby macros are in NapaRuby-transformed-macros. And they can be moved, if you want to take them away from transformation, they can be moved to NapaRuby-macros. So just take the transformed away, and then they will not be included in transformation anymore, and they are and later they can be moved to any other place, but that is the first stop after, if you want to take them away, and I'm happy to show anyone example of here. Okay, let's see if I was missing something here. Okay, but we are out of time anyway, and these are developers, valid developers from developers, valid questions. So let's continue this discussion, for example, in the developers flow. You can post more questions there, and I can answer their technical questions. Okay. Thank you, and bye.